Check out LiTime's Go Electric contest with our link in the video description. I'm going to take this battery box and keep it up here in the bow, and then this one is going to go right here, sort of amidships. Inside of each box, I am planning on having the fuse right here, and on this box I'm going to have this on-off switch right in here, so we'll drill a hole for that. Then we've got a whole bunch of these Amphenol plugs. We're going to have the positive cable here on the starboard side and the negative cable here on the port side. So this is going to go right here. That's right where the bolt is going to go. On the negative side, that one's going to go right there. Negative, positive. And then on the forward box, this is going to go there, and that'll go there. And then to connect this battery to the outboard, the cables are going to come out the starboard side, negative one right there, and then the positive one right next to it. And then finally we've got the switch. It's going to go right there. Yep, right about there. I'm just going to take the battery out before we start drilling. To secure these webbing straps in here, I just took a piece of marine grade plywood and used my router to make a little indent there for the webbing strap to go through, and I sewed the webbing strap there before I screwed the piece of wood into the box. And at some point in the future I might take this off and then epoxy it onto the box for added strength. I don't think it really needs that. The screws are strong enough to hold the battery down, and then I might paint that wood, but it's fine for now. All right, let's start drilling some holes. So first I need to drill a hole in the wood for the center part of the Amphenol connector to go in like that. Okay, here we go, drilling holes. I'm going to put this piece of wood right there so that I don't damage the inside when the drill goes through it. Our first hole. Please fit. Yes! There you go. Wow. Just use the Amphenol connector itself as a template for drilling the holes for the screws. Here's the first hole for the first bolt. I just drilled 4 holes for the 4 bolts for this Amphenol connector. Bolts will go in like that, and then I will put a washer and a nut on the inside to tighten that down on the box so it'll be very solid. And the Amphenol connector will go on like that. Look at that. All right, do the other 4. Perfect. All right, so the bolts are going to go in like that, and then each one's going to get a washer and a lock nut. So I've got the receptacles in place. They're in the correct orientation. They've both got the gaskets on them and the bolts partially inserted. Now comes the messy part. I think I got to use Sikaflex to make sure that these bolts are completely waterproof. Didn't even get any on my hands. Here we go with the washers and the first nut. Just going to take off the excess with a little bit of mineral spirit and a paper towel. And that will go there. All right, now that the receptacles are all installed on the boxes, it is time to make the plug cables. Next, I'm going to make the positive cable and the negative cable with the Amphenol plugs to connect the two boxes together. Now for the Amphenol plugs, you just undo this, slide this onto the cable, take that much off the end. These Amphenol plugs are meant to be crimped onto the ends of cable, and they can handle much larger cable than what I'm working with, but if you are using a smaller cable like I am, then they have these little inserts that you can put over your cable and then put that into the plug. And you just do it until you can't do it anymore. And now our plug is solidly crimped onto the wire. Then you put the gasket over everything and tighten this down. And now you've got a completely waterproof plug. It's amazing. I'm going to set up the negative one now. Negative cable is going to plug in right here. Locked on. Positive cable will go here. Locked on. Now I will make a cable that goes from the Amphenol receptacle to the negative post. Okay, I'm just going to put a piece of heat shrink tubing on the wire. So this is going to go right there. And connect to the battery post right there. Okay, might as well do the positive. Okay, I've got the positive cable connected to the Amphenol receptacle, and I've got the other end insulation stripped back, and then this is going to go into the fuse holder like that. Okay, here. This battery is fused. We'll tighten up on the connections tomorrow. This is very much done. We're calling it quits for the night, and we will continue this tomorrow. One thing that I forgot to mention is that these Amphenol receptacles have these waterproof plugs, and you just stick them in like that, and then you've got a waterproof seal on the receptacle. If you don't have a plug to go in it, you can just put the bung in there, and then it's waterproof. Tomorrow we will finish this and we will take a ride. I can't wait. Here we are the next day, and it is quite sunny, and we have to get this job finished today because tomorrow it's going to rain. So we've got the forward battery all wired up, and the cables from that battery to this battery box wired up. Now we're going to do the wiring for this box. I'm going to start with the cable going from the positive on this battery to the Class T fuse. From the negative Amphenol receptacle, I'm going to go directly to the junction block. Now we'll do the positive Amphenol receptacle to the switch. Now I've got all the wiring in place from that battery box to this battery box. The negative circuit's coming in and connecting to this post on this negative junction block, and the positive circuit's coming in and connecting to this post on this on-off switch. Now I'm going to make up cables to go from the negative post and the positive post on this battery also to the negative junction block and the positive switch. It's really important that for each of these cables, the length is the same as the total length of the cables that are coming from that battery. So the negative cable going from this post to the junction block needs to be the same length as the total length as a cable from the negative junction block all the way to the negative post on the other battery. And the same thing for the positive cable. And to do that, I'm going to take all these cables off and measure them to make up the new cable. We'll start with the negative. I dropped a nut in the battery box, but it's secured in there with the webbing, so I can just turn it upside down. There it is. It takes a little bit of effort to undo these plugs, but not too much. Now I've got our 3 negative cables that went from that battery box to this one. I'm going to measure the length out and get our negative cable. So I'll go there. That should be about the right length. Now we'll put the negatives back in. This time I'll tighten down on the connections. Now we'll make up our negative cable to go from this battery negative post to the junction block. I'm just going to snake this negative cable around the battery itself. So I've got the negative cable connected to the negative terminal on this battery, and then it's snaking around the airspace around the battery and then coming to the negative junction block right there. And then the cable from the other battery is coming in and connecting to the same post right there. Nice and neat and secure. Now I'll make up the positive cable, and we've got to undo all the positive cables so we can get the length right. I like to use Class T fuses made by LiTime. I like the holders that they come in. They definitely have the high interrupt capacity that the Class T fuse needs to be used with a lithium iron phosphate battery. I did see some Class T fuses on Amazon. They said they were Class T fuses, but they also had the spec for the amp interrupt capacity, and I saw that that number was not as high as it needed to be, so they aren't really Class T fuses as far as I'm concerned. Here we go. And then we've got this other cable length right to there. Very little cable left over. Now I'll put the positive cable back together on that battery. Here's our second cable. And now for this one, I'm going to coil the cable around. I'll wire tie it all together. This connector will go like that. This 90-degree angle connector is going to be pretty convenient for this. Just going to wire tie everything together so that there's no movement of anything in the box. Yeah, that's good. Finally, I'm going to make the cables that go from the negative junction block to the negative amphenol receptacle and the other side of the switch to the positive amphenol connector. And once again, a 90-degree connector is going to come in pretty handy for the cable that goes from there to the Amphenol receptacle. Finally, we've got to get the negative cable from the negative junction block over to the negative Amphenol connector. Now we've got the two batteries wired up in parallel, and all of the wire connections are very solidly set in place with wire ties. The two batteries wired up in parallel are connected to these two Amphenol receptacles. I'll plug the electric trolling motor into these receptacles with Amphenol plugs. I'm also going to hook up a battery charger to these plugs so that we can charge the batteries up to full. I've got a 40 amp 24 volt lithium iron phosphate battery charger right here. It just plugs into an AC outlet, and then it has a positive and a negative cable coming out of it to plug into your batteries to charge them up. I'm going to replace these stud connectors with Amphenol plugs. One last thing I forgot to do, and we'll do now, is I'm going to add some Sikaflex underneath the battery selector switch right here to waterproof it to the box. I've connected Amphenol plugs onto the ends of the battery charger cables. I'm going to plug them into our receptacles, and we're going to charge our two batteries up to full. Comes the positive, and here comes the negative. I'm just going to run the LiTime app. You can log into an account, which gives you some benefits, but you can also click on guest mode if you're not online. And then if you click on device, here are two LiTime batteries picked up with Bluetooth, and it says that each one is at a 50% state of charge. If we click on one, then you can see the voltage, the total number of amp hours that are currently charged into the battery, the amount of current that's going in or out of the battery. Very importantly, you can see the temperature. We are at 17 Celsius right now. The BMS on this battery will shut the battery down if things get too hot or too cold. You can see the number of cycles, which is fantastic. We're going to get at least 4,000 cycles out of this battery, charging it to full and discharging it down to 0. Now we're going to turn on our battery charger. I've got our battery charger plugged into the batteries. I'm going to plug it into the outlet. Battery charger is turning on, and we are now charging our two batteries in parallel. You can see 7.8, 8.4, it's building up. The battery charger is building up its charge, so these numbers will stabilize in a moment. The LiTime app is telling me that both batteries will be fully charged in 1.17 hours to a full charge. They are each getting a charge of 21.5 amps. They'll be fully charged in 1.7 hours. Fantastic. I am thrilled. I am really thrilled that we can charge these batteries this fast. Let's look at the other battery. It's got 20.6 amps going into it. If these batteries were both fully drained down to 0, then this 40 amp battery charger would charge both of them up to full in under 3 hours, which is fantastic. I don't think I'll be draining the batteries all the way down to 0 in between charging. I probably won't discharge the batteries down to 0 that often, but it's good to know that if the batteries are fully discharged, then they can be charged up to full in less than 3 hours with this battery charger. Oh, it's amazing. In the past 10 minutes, I've watched the state of charge on each of the batteries go from 50% up to 55 and 56%. They are screaming up to 100%. Now that all the wiring's done, I'm going to put the waterproof covers back on, and I don't anticipate needing to open these boxes up for anything because we've got access to the batteries from these two ports. that's it. I just think this is so incredible. Just being able to charge these batteries up to full so quickly and then have so much energy for so many hours of the trolling motor. The trolling motor goes at about 5 knots. It's actually the equivalent of a 5 horsepower gas outboard. And I'll never have to buy gas again because we're just going to charge these batteries up easily using our solar panels. Electricity is pretty easy to generate for free with the sun, or just plug into a power post. Free propulsion from here on. Tomorrow I will take her out for a spin and I'll show you the outboard. It's a little while later. Thought we'd check on things. We are at 88% charged, 20.3 amps coming in. Estimated time to full charge is 0.29 hours. Temperature has gone up to 24 degrees Celsius. So temperature has come up a little bit, but still well within the range of what's acceptable for temperature for these batteries. In half an hour we'll be done, and then I'll disconnect the battery charger and put the waterproof plugs in the Amphenol receptacles to waterproof the receptacles. And then tomorrow, if it doesn't rain, we'll take it for a little spin out of the marina and into the harbor surrounding Moana, Spain. Well, I guess we're not going to go for a ride in the dinghy today. We're getting quite the deluge, and I'm sure the dinghy is, filling up with water. The boxes are completely waterproof, and the Amphenol plugs are waterproof, so I'm not worried about any water getting at the batteries. You know, I just had an idea. I could get a 24-volt bilge pump and connect it to some Amphenol plugs and plug it into our battery. I could put it on a float switch, and I'd know that if it rained, it would bail out the dinghy. That would be cool. The rains have stopped, but boy, did we get a lot last night. The dinghy is full. The boxes are in quite a bit of water. Everything is soaked. I definitely want to install a bilge pump. 24-volt bilge pump with a float switch. I can bail the dinghies as it fills so that I don't have to do this. The paint on the boxes is really durable, but it's not meant to be used under the water line. This is our electric trolling motor. We keep it mounted here on the stern rail whenever we're not using it, and I made this custom canvas cover for it using our Singer heavy-duty sewing machine. If you want to see our video about our awesome sewing machine, there's a link to it in the video description. The cover is fantastic because it protects the trolling motor from the sun, but more importantly, I think, from all the salt that covers 100% of the exterior of the boat every time we go offshore. I made the cover in 2 parts. There's a bottom part that goes around the propeller and the motor, and then the top part, which covers the tiller. I put the bottom part on first, and then the top part comes down and goes over it and then secures tightly over the bottom part with this webbing strap. There's also some Velcro in there. I'll take that off first. The bottom part is just hanging in place by these strings. In addition to protecting the motor and the propeller, I also conveniently use the bottom bag to store the cable that goes to the battery. You can see right here I put Amphenol plugs on the ends of the cable. If I push this lever, then I can tilt the thing out to varying degrees, which makes it easier to take the bottom bag off. And there it is. No salt. The trolling motor weighs about 27 pounds, so it's not too heavy. It certainly would be almost impossible to carry if all the weight of the battery was also integrated in the motor itself. So having the battery and the trolling motor separate makes it a lot easier to get into the dinghy. This trolling motor is rated at 120 pounds of thrust, which they say is equivalent to a 3 to 5 horsepower gas outboard. The trolling motor came with 2 wires coming out of it and a different kind of connector, and I just snipped that off and used butt connectors to connect my own 16 square millimeter cable, and then I put this protective cover over the wires. Here are 2 Amphenol connectors and our Amphenol sockets with our plugs to make them waterproof. And actually, when I just open this up, you can see that it is completely dry inside, even though it was in water up to here from all the rain that we had last night. I'll put in our plugs. It's 1 and 2. Now I'll turn the batteries on with the switch. And the trolling motor has a voltage reading. It says 26.7 volts right there. We are ready to go. I'll just run our LiTime app and click on guest mode and continue experience and then device. And here are our 2 batteries. We'll click on 1. It says updated 0 seconds ago. This is a real-time connection with the battery. We are at 100% full charge, 26.9 volts, no current going in or out of the battery. We have an actual capacity of 50 amp hours in the battery right now, and temperature is at 18 degrees Celsius. We'll just check on the other battery. It's all the same thing, 26.8 volts, no current, 50 amp hour capacity, and 18 degrees Celsius. I was hoping we were going to have a day without too much wind and no rain, and I see rain on the horizon approaching us, and we also have quite a bit of wind, but we'll see how we do. And away we go. Welcome to Moana Marina. This is just beautiful. You can see here on the chart plotter that we are just leaving our spot in the marina and going down this length of boats on either side. We're going 2.8 knots steady, and if I look at the LiTime app, then you can see that we're drawing 3 amps per battery, so a total of 6 amps altogether, and we can maintain this for 19 to 20 hours. That is not too shabby. 18 hours at 2.5 knots in calm conditions. Let's see what we can do if we go a little faster. I'm just going to wait until we get out of the marina before I open up the throttle. Again, we're drawing 2.5 amps per battery, 5 amps total, 20 hours, 19 to 22 hours remaining usage. And our speed is steady at 2.7 knots. Oh, it's just so nice to be out on the water again. We arrived here in Moana about a month ago, and we haven't taken the boat out at all. We haven't taken the dinghy out at all since we got here. We've just been exploring stuff on land, but there's a whole world out here to see on the water. Just beautiful coastline, lots of beaches, other towns that we can go to along the coastline. It's just, and also fishing. There's lots of fishing that happens out here in Moana. Out in the distance, there are actually a lot of fishing farms as well. Now we are more out in open water, still going a steady 2.5 to 2.8 knots and drawing about 5 amps, 99% charged, 19 hours remaining. Now going to turn up the throttle. We are now drawing 25 amps, and at this full throttle we have 1.9 hours remaining. So we got 2 hours of energy at this speed, and our speed is steady at above 4.5 knots. Yeah, we are really, really moving. I actually think I could use a little more weight in the bow to get the bow to go down, and that might help our speed as well. Normally, Monique would be sitting in the bow, and so the weight would be distributed better now. It is so nice to be back out on the water. You know, so many people live on land and they never get to experience being on the water. But with our batteries and our trolling motor, it's easy to just zip out and see what's going on out here. The marina's way off in the distance now, and I'm not sure what this big structure is here, but the birds are really into it. I think I'll check out that other marina way down there. Beautiful day to be out on the water. A great thing about this trolling motor is that it makes a lot less noise than a gas outboard does. I mean, with this motor, you can actually hear it, but it's not loud, and I think I can only hear it as much as I can because I'm right next to it. Wildlife in the water or on land that we're passing by probably can't hear it. So definitely one thing worth noting is that when we're full throttle and going at a high speed of 4.5 to 5 knots, we're definitely using a lot more amps and thus would have a shorter run time. But if you decrease the throttle, then you're using way less. Yes, you're going a little slower, but you can go a lot further and for a lot longer. Always worth keeping in mind. We're now about 20 minutes into our voyage and going 3.5 knots, and we've got 5.5 to 6 hours of energy remaining on the batteries. So we can do long trips with these two batteries. I also feel like this is kind of like a momentous moment because we're actually using our first cycle out of these batteries out of a minimum of 4,000 cycles. And if we don't deplete the batteries down to 0 every time we charge them back up, we could get twice that or more. So it all starts now, and this is cycle number 1. Looks like there's a little restaurant there. We could tie up the dinghy and go get a bite. Just doing a little sightseeing tour. No, not going anywhere in particular. Just out here to test speed and figuring out what our range is with these batteries. I'm now plowing into the wind, and it's a lot bouncier, a lot wavier, a lot splashier. We're drawing 14 amps with 3.5 hours of charge remaining, and we are maintaining a steady 3.8 to 4.0 knots. A little splashier, but it's not too bad. Yeah, I think this is fantastic. Really pleased with the amount of energy that we can store in these batteries, the speed at which we can charge the batteries up to full, the fact that we'll get 4,000 charge cycles at the minimum, the fact that we can go at a good clip of 4.5 to 5 knots. We have enormous range, especially if we don't go full throttle. We can cover many nautical miles on a full charge, which means we can go far away and explore the coastline in the places that we sail to. We also depend on our dinghy for so many things, especially because we spend a lot of our time at anchor. Everything to do with getting to shore, getting things to shore, getting things from shore back to the boat, taking out the trash, getting the groceries, getting, all kinds of supplies for the boat. it's all done with the dinghy when we're at anchor. So having a dependable way to get ashore and back, and also over long distances, it's like a really big deal. Also being able to charge these batteries for free because we have the solar capacity to charge them to full every single time. I think it's a really good setup. Not having to buy gasoline the novelty is not wearing off. Not having to find where to buy the gas, not having to store the gas on the boat, just always wherever we are being able to generate the energy we need to charge the batteries from our solar panels and our wind generator. If you're gonna go sailing all over the world, I think this is like a great thing to do. It really extends our options. Okay, so let me do some math. We're going 4.5 knots and we have 2.09 hours remaining. Gives us a range of 10.2 nautical miles. So we can go at this speed for 10 nautical miles. Yeah, we have a huge range. Clouds getting dark. I think the rain is approaching. Just come back to our marina. It's definitely starting to rain. It actually looks like we're gonna get a deluge. So I just made it back to the marina and we are barreling back to our little spot down there. Hello! Yeah. 5 knots. I am pleased. The batteries are working great with the trolling motor. No problems powering it. We have enormous range now. I think we can easily cover 10 to 15 nautical miles at a good speed. So, hope you enjoyed the video. We'll see you in the next one.